Hi, welcome everyone that's gotten here so far. My name is Debbie Heiser, and I am welcoming you from the Mentor Project. Today we have Bill Cheswick, who's presenting on rethinking passwords. What I'm going to ask everyone to do today is to please mute your audio, and if you have questions, feel free to enter your question in the chat box, and at times Bill may say, hey, go ahead, ask a question if you'd like. Feel free at that point to unmute your audio and ask a question. And I hope that you enjoy this presentation. I'm going to turn it over to Bill now.
Well, thank you, Debbie. This is, of course, the sort of thing that's happening all over the world right now. People are not in classes, they're doing this. I do not like this form of presentation. It's a very cold medium. I'm talking to an empty room. Hello, and an unknown number of people out there. I like to look at the faces and see who's falling asleep. My house, but it is my house. It just reminded me that tomorrow is trash day, and it may have other things to say in this. What I have today is a talk I've been giving for quite a while, and I'll get into a little bit of the reason why pretty soon. I've been giving this for, oh geez, maybe 15 years in various forms. However, today I have a whole bunch of new slides. So it's going to be kind of maybe a little disorganized. We'll see how it works out. You know, if I'd had less time, I could have prepared it better, I think. So we're trying this medium here, and we'll see how it works out. You'll notice that I have a sort of progress bar in the lower right-hand corner of the screen. The government rule recommendations for slides is that you spend 4 minutes per slide. I am not planning to do a 400-minute talk here. I find that it's more like 2 minutes per slide for me, and you'll see that some of them go pretty quickly. So this will at least give you a little bit of a progress bar. Unfortunately, they're not automated. I have to go in and do that myself to put in the 100. All right, so let's see what we got in here. Okay, I was just thinking that perhaps I might start a new bank in these troubled times called the Corona Savings and Loan. As you can tell, we have a lousy marketing department, but everybody hates passwords, and this would be a trusting bank with no passwords at all. Well, of course, after a couple days of trying no password banking, we have the online bank with easy passwords. Maybe if they're easy, it would still work. So easy passwords would be a single digit from 1 to 8. You've got a choice of 1 out of 8 passwords. You could pick whichever one you want. And of course, that means people might want to guess. So we have another feature at our bank, which the marketing department does not like, our new dynamite chairs. So when you sit on your chair and you guess the wrong digit, it blows up. So you get 1 try. And so here's if we're now in the bank running the server, the other end, we have a password file. And I hope you can read these. These clear enough, Debbie? That's the Monaco, I hope so.
Yes, everything's clear.
Excellent. So here are 10 names I picked at random from suggested baby names. And there are 10 users, and those are their 10 passwords. And when William logs in, his password is the number 3. And we would look it up in this little file. This is a file we have on the machine. Now, this file is a problem because if we have a bad guy in our bank, and friendly banks might, or if someone breaks in, they can see William's password. And that's actually not such a good thing. So what we can do is we can make a hash of it. And the hash looks like this. And what a hash is mathematically take, in the case of line 1, the number 4, which is the whole password, and we chop it up mathematically and we get that string of gobbledygook. And I'm not going to go into too much detail about that string of gobbledygook, but you will notice that everybody who has the same password has the same string of gobbledygook. So the string of gobbledygook is associated with the number 4, but it isn't clear how you get the 4 out of the gobbledygook. But we still have the password, so we have to change this file so it looks like this. So we don't actually have the password, we just have the hash of the password, which means when someone calls our bank, when Liam calls our bank and asks what his password is, we don't know. I mean, we know since there are 8 passwords, we know all 8 hashes. We'll get to that in a moment. So a hash function chops up the number. It's a one-way function, we hope, meaning you can compute the hash easily, but you can't go from the hash back to the password. It's supposed to be really, really hard, taking the age of the universe to do that. It's also supposed to be really hard to find another input, another password that hashes to the same thing. And this is all the mathematician for it. It's supposed to be hard to compute the original hash from the hash alone. And if you're not following this, it isn't that big a deal. I'll give you a couple of examples and then we'll go on from this. So here's an example. Here is a hash, and it's a whole bunch of hexadecimal characters. That input came from this number, which is 50 digits long, I think, or something like that. And it's certainly not clear how that number made it to that hash or even where that number came from. Turns out, our little secret, the original input is from 40 factorial. If you computed that, you get that number and you get that hash. But that gives you some idea of what's going on. And for you technical types, and this will not be on the final, I used a 256-bit HMAC algorithm with the keys Corvid, savings, and loan. Okay, so marketing and legal and our new company report that the dynamite chairs are a problem. We're losing our customers. Could we have somewhat longer passwords, like 4 digits, and maybe only let them log in, try 4 times? And we save a lot on dynamite expenses and lawsuits. So my first ATM, I mean, these things are all over the place now. I think it was about 1972. And this was really cool because before that, if you wanted to get money out of your bank, you'd have to go inside to the teller and talk to a person and give them a passbook or something, and they would give you your money. Maybe you'd give them a check. And they were open at the convenient hours of 9 a.m. to 3 p.m., except maybe 5 p.m. on Wednesdays. And they were often closed on the weekend. So you couldn't get your money very easily. And then these machines showed up, and you could just walk up and put your card in and enter your PIN and tell it how much you wanted, and you get money out of it. And this has been working for what, almost 60 years now. Now, here, from a password point of view, you're entering a 4-digit PIN. It's only 10,000 passwords, which from a computer's point of view is not that much more than 8. And it has worked for a long time. The Europeans have 6-digit PINs. We are much more secure. We have 6 digits. But it turns out, no, that doesn't really matter either. The 6-digit PINs, in one paper I read, were actually less secure because people picked lousy PINs. So the number of tries is limited by authentication. So you can't sit there and try all 10,000 because it'll eat your card or turn off your account. And this is important. If you limit the guesses, then the password doesn't have to be too fancy. And there are about 1,000 bad PIN choices. And I've read papers where they go through and actually pick them 1111, 1234, and any date, bad idea. So actually banks won't tell you the list of PINs you can't choose, but there are some there. Here's a study, I don't know if you can read this at all, a study of the most popular PINs that people use. This is hard data to get. 1234 is the obvious one. It's what you try on bathrooms too, right? And 1111, 0000, and get down to 1010, and you're down to 2%, 0.2%. Ooh. And, but what if they get access to our password file, the thing at the other end that has our password or the PIN or the hash? Suddenly they can do whatever they want with that file. You know, we need to have that file be hashed because of insider attack, the 3 Bs, burglary, bribery, and blackmail. You know, can you get the insiders to do it? It shouldn't happen, but it often does happen that they get to that inside file that has everybody's account and password on it. So this is what that file might look like. I chose, instead of 8 passwords or 10,000, I chose all the words in the list of English words, 74,000 words, and put it in there. And you can see the hash. It's quite daunting. It's just all these numbers. But if you want to know what the word was that William used, you'd have to write a little program called the password cracker that would go through and guess. Is it 1? Is it 2? Is it 3? Is it A? Is it B? Is it the? Is it cow? You'd have to guess, well, a lot of words. Now, computers can do that really quickly, but at least it's a little easier than 1 through 8. So, by the way, the words are for them were vermin-footed, all divine, wet air pump, Eden sold, strawberry fern, etc. These are not normal words, but that's fine. Here is an actual password file on the left that I had up on the internet back in the late 1980s. And you can see the first line there has root, colon, and then some gobbledygook, that's the hash, colon, and then some information. And the ones in the blue there are the various hashes. And I actually put up a little puzzle for the hackers to come and get, because people often left real passwords hashed in there. And you could connect to a machine on the internet, grab this particular file, run it through a password cracker, and find out what the passwords were to the machine, because you could guess them. You'd have your computer guessing them. Now, it turns out here on the right, I've put in red letters what the word was that got translated into the hash. Why are you wasting your time? I actually got a call from AT&T corporate security once saying, the bad guys have your root password. Oh yeah? Yes. What is it? Why? Obviously, these weren't the real passwords. I set this up just to sort of torture the bad guys. So a file of passwords is an oracle that we can consult on our own machines. That means we can run through these guesses as fast as a computer can go. And we'll see how fast they can go, which means it gets really hard to do it. Let's see if we can hear this.
Open sarsaparilla, open Saskatchewan, open septuagenarian, open saddle soap, open sesame.
So that was a Bugs Bunny cartoon from the 1950s. That was a dictionary attack on the cave door in this case. You may have noticed there was also he had to flick his hand too. It was actually 2-factor authentication, and we'll get into that. His name is Hassan, and of course, as a security person, one wants to know, why does he need to know the password to the cave? You don't tell the bank guard how to get into the vault. He knew it began with an S. He made 5 guesses in 13 seconds. That's a little under 300 guesses an hour, which means if he went through all the words in my dictionary, it would have taken 90 hours or about 3 3/4 days to run through all the words to open the gate. Of course, he'd probably find it about halfway through. By the way, if someone bad gets into the cave, his boss told him he'd be fed to the jackals. And most system administrators do not sign on with a jackal clause. So the Department of Defense back in 1985 put out a list of recommendations for passwords. How long should they be? How quickly should they be changed? And so on. And they assumed that you could guess at about 120 characters a second, which is pretty slow. And they said for reasonable results, it might take a year to do something. It was okay, but this was really slow. And if you take the equations, the recommendations they used back then, they said you should change your password every year and it should be so long and so on. That I did a little calculation. If you use their math with current access speeds an 8-character password can be cracked in 6 minutes. And I'll talk about the rest of this. And that means you should change your password every 400 microseconds. But we still follow those. So the dictionary attack has a computer try as many passwords as it can. And the required effort is called the work factor. And the resistance is the entropy, which I'm not going to get into today. And they can be directed at online and so on. But the deal is the computers have been getting, well, they've doubled their speed 12 times since 1990, which means they are so much faster that they can do an amazing number of guesses per second. And in fact, when I last checked, it was 8 billion guesses a second. So that means our dictionary would get it in a few microseconds. It's just, it's much too fast. So has this been working? No. Here are some of the password cracks. The passwords lost over the last 10 years or so in millions. Now, of course, something like the Equifax password, what they get are the hashes, because almost nobody stores the actual clear password in there. They get the hashes, which means people have to crank through and do this password cracking. But you can do an awful lot of it. Oh, this is quite a list. And you know, some of these, I mean, Equifax, but the USOPM is the Office of Personnel Management. That was the information on everyone who had security clearances. Yeah, that was me. I had, yeah. And what do you do? I mean, the Chinese have it now. Turns out they don't actually have your fingerprint. They have a description of the points on the fingerprint, but still. So what are the top passwords? People have studied that. Sorry, these periods here were an artifact of my typing this in. 1, 2, 3, 4, 5, 6. There's a surprising password. QWERTY, password. I don't see swordfish on here, but it's pretty common. Monkey, dragon, I love you. A lot of people, this will come as a surprise to many of you, I'm sure. A lot of people cuss at the computer when they log in. It asks for a password and they type in bad words. I'm not going to show those here. Here's some more top passwords: names, Ashley, football teams, fictional characters, musicians, and so on. Oh, all right. I'll show you a way to cuss at it later. So what can we do? What do we do? Well, we want to make the passwords harder for the computer to guess, but we really not, I mean, 74,000 words is a lot of words, but not much. So Intel says the password must be at least 8 characters long, 1 alpha, 1 numeric, 1 special character, must not contain spaces. For some reason, spaces are bad in passwords. I don't know why. Must not begin with an exclamation point or a question mark. And they're case sensitive. Upper and lower case are different. Dartmouth, at the time I got this, had the passwords had to be exactly 8 characters long, not longer, not shorter. Upper and lower case, no more than 4 characters in sequence, cannot be found in a dictionary, including foreign languages. So no Estonian words, please. Cannot be a reversal of a word. And you're not allowed to replace zeros with O's and so on and that sort of thing. JP Morgan Chase, just back in December, 8 to 32 characters long. Well, there's that 8 again. At least 2, 1 letter, 1 number, special character, and they give a list of the special characters. There isn't clear whether space is in there. It must be different than your 5 previous passwords. You must not match your user ID. No more than 2 identical characters. XXX. Some people just go XXXXXX. Not 1, 2, 3, 4. Can't be JP Morgan case. Cannot be commonly used password. They must have a list of those. Bank of America, 8 to 20 characters. 1 uppercase, 1 lowercase, 1 number. Do not repeat the same numbers more 3 times in a row. Wells Fargo, 6 to 14 characters. Those guys with 28 characters must be doing it wrong. Not 9 or more numbers. Not identical to your username. Oh, these go on and on. Citigroup, 6 to 50 characters. ABC is not the same. Okay, uppercase matters. Mitsubishi, new password 8 to 32. Spaces not allowed in your password. Why? It's the easiest key to hit. Capital, small letters are different. Okay, well, you get the idea. I call these eye of newt password rules. from the magic formula in the Shakespeare play Macbeth, where they add I of newt and toad of frog. Yes, you need these characters and this character and this character. They're hard to type. I'm a fast typist, but you start throwing in special characters, that slows me way down. I'd rather give you 2 extra random words because I can blurt out words fast. Oh, and use a different password for each account. If the attackers get one password for one account, they'll try it elsewhere. That is true. Change your password frequently. Well, that's what we used to do in cryptography. When you got a key, you got to change it often. If the Germans didn't do that, it was a big problem in World War II. Don't reuse your passwords. Don't write your passwords down. I don't know about you, but I got a flock of 20, 30 passwords that I've got it, and I'm going to write them down. I'll talk a little about that later. And this is a usability nightmare. They're easy to test, but hard to type and remember. And who's responsible for this? Well, maybe I am a little. I wrote a book on internet security back in the early 90s with Steve Bellovin. And if I had a time machine, I'd go back and write a few sharp paragraphs about what not to do with passwords. We talked about passwords. We didn't talk about this mess that we've gotten into. Maybe it would have made a difference because a lot of people were first writing this stuff. And of course, a lot of this code is old. So people violate these rules all the time. Surprise, duh. Stringent rules mean that you use fallback systems. If you forget your password, then you're typing your favorite music or your first pet's name or your mother's maiden name or stuff that actually can be easier to guess. And they don't make things more secure in the face of most current threats. I'm going to talk about grandma occasionally in this. The person I called grandma was no dummy. She helped Seaborg and Oppenheimer discover new elements, okay? She wrote disk controller code for the UNIVAC 1. She was no dummy, but that doesn't mean that she's an internet security expert who knows why we have all these I of newt password rules. I'm hoping by the end of today, you will know. And of course, none of these security problems are grandma's fault. It isn't the users, it's a problem. This is crappy engineering to expect people to select and enter these long strings of things so somebody can't guess them with a computer. Can we do better? Oh, yes, we can. I'm going to talk about a bunch of that today. So back in 2008, in the April edition of eWeek, IT eWeek, I'm sure you all read this carefully all the time. They listed the 100 most influential people in information technology. And I was right there at number 98. Boy, they were scraping the bottom of the barrel. You can see Ben Bernanke was 100. He was the chairman of the Federal Reserve Board. I'm not sure what he had to do with information. And I thought, sort of like a Hollywood starlet who wants to save the whales, now that I'm famous, what can I do? Maybe I can help fix this password problem. Maybe. And I've been giving this talk ever since. And it turns out it's not so easy because it's hard to change the code. So there are 4 factors for authentication. Something you know. PIN, mother's maiden name, the word, the phrase, whatever it is. Something you have, a device, cell phone, a key, a car key, something implanted in your skin. Something you are, your fingerprint, your face, DNA, voice prints, we test all that, how fast you type, how you move a mouse, your location. You know, I don't usually buy computers from Latvia. So if I'm trying to do that, that's a pretty good indication that it's probably not me. But there are also factors where they actually have a smartphone have you speak and see if your lips and the sound happen at the same time. You know, sort of sonar ideas. There are lots of people, academics are going crazy with this. I'm going to show you a bunch of it. So here are some password ideas over the years from academia and me. And for a complete survey, by the way, these slides will be up on my webpage and on the Mentor Project when we talk to Larry about this. So you can go check these if you want. This was actually, I guess this is 10 years old now, isn't it? It's a survey that Paul did. Okay, so one is you show somebody a picture and they tap something on the picture. And if you tap the right part, that's your password. Okay, pretty good. Turns out this paper said people tap the same places. So there aren't as many passwords on this picture as you might be. We'll get onto that. Here's one which was called Pass Faces, which was a big deal around 2000 or so. The idea is that they'll show you 5 screens of faces, and you have to remember the face that's yours, that's in your group each time for each screen. Now, I'm pretty lousy with names and faces, but I tried this. Those were the 5 faces that I had. Here's the list of my first presentation. You can see the young lady in the upper left was my first pass face. And then there's the guy and so on. And I tried it after a day and a week. And you know, sometimes you only log in once a year, like to update your medical insurance or something like that. I wanted to see if I could remember these faces a year later. And actually I did. So that sort of worked pretty well, and that was pretty good security. By the way, these people were college students who volunteered to have their faces done. It was sort of interesting. Or we can use computer-generated art. Can you remember the art? Here was an early one of past phrase, past patterns. Android has this too, but you could imagine picking up your phone and waving it like a magician in some magic way, and that would be your password. Though if you get it wrong, I'm not sure how the person on the phone will help you with that. Use your illusion. Take your pictures and fuzz them up, and then ask you which one is yours. It's an interesting idea. And zoom and tap. This was an idea. I think I actually got a patent for this, and we're going to go into a use. I had an app in the App Store for a while for this. There's something online I will show you shortly on how to use a position on the world as your password, and it's a pretty good password. See, what you do is you remember how to zoom in where you're going, and you find some place like maybe that car on the right, and that would be your location. Or you could zoom into the Mandelbrot set, which is the first practical use of the Mandelbrot set I've ever seen. My app also lets you zoom in on a calculus book. So you pick a page and you zoom way down into a particular character. So what you really want is a one-time password, something that someone can look over your shoulder and see you type, and it won't be useful for them. And, so here is, that guy is a third base coach, and he's sending a signal to the base runner here. Let's watch that again. Tap, 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 face, nose, arm, nose, nose, face, forehead, chest. Okay, good, I have that looping. Stop it. What he is doing is sending a very simple signal to steal or to hit and run or whatever. He's sending a short message out, and everybody's watching, and somehow the player figures out what's in there. And I wondered if the computer could send some sort of signal to the person logging in, and the person logging in could use the same sort of techniques that baseball signs use to pick out what the answer would be. You know, and this sort of work. Baseball players are under a lot of stress, not always the sharpest knife in the drawer. Babe Ruth was said to have forgotten the signs 5 steps out on the field when he left. Maybe they could obfuscate. So the approach was something like this. And I tried it on myself. I set up a little program which typed out that line of text, the name and the date and some gobbledygook. And I had to look in the gobbledygook and figure out what the right answer was. Now, it's got to be obscure, but not hard, because I'm not solving second-order differential equations here. And you can see that it all worked right up through December and January. And then by January 18, I started getting tired of doing this. And in fact, on the last ones, the 222, 5 from the bottom, was a correct answer. And frankly, I don't remember exactly what the algorithm was. But you had to pick certain letters out and a number out and add 1 to it. So the A, B, 3, K, D, H, D, F, and the third from the bottom, it's the 3 that's important. Anyway, the idea was maybe we could do something where you could do some computation in your head without needing anything more than that. And so I wrote a paper on that. and it was hard. I don't think it would work very well, but it might be good for an emergency password. So, can something you know be saved? I think so, and I don't think we have a choice in some cases. Something you know, something you have, something you are. We got to limit the guesses, lock the accounts, or at least slow down the tries. We've been doing that for a long time. Multi-factor authentication, we'll get to that in a moment. Password vaults and authentication tokens, devices. We're going to talk a lot about that, or a bunch. So multi-factor authentication is where a lot of people use it now. Something you have, something you know, something you are. Where you are, your phone number, I talked about this. Your email password is probably the most important authentication item you have, because if you forget stuff, they're going to send you your email. And if someone takes over your email account, or if you lose your email account and someone else gets it, they may be able to log in as you. So combinations of these are a lot harder to test. So let's get out of the game. Let's stop having people memorize stuff. Here was a device I used at Bell Labs. Cost about 50 bucks. It has a long secret you don't have to know in it. And what you do is you turn it on, you enter your PIN, which unlocks it, and then you give it a challenge. And the computer, this is an actual login session that I used. And I've shown this to the world. It said, okay, you're logging in, authentication server, your ID, I'm Ches. Enter response code for 70202. Well, I unlock the thing with my PIN, I enter 70202, and it comes back with that number. Now, if you were to try, and then it says, okay, where do you want to go? I'm going to go to CETUS, which was the computer name. So if you tried to log in, it would give you a different number, and you wouldn't know what the answer would be because you don't have the secret that's in there that's doing the computation. This is very handy. But you got some problems with it. First of all, some people complained that this was too hard, especially CEOs and stuff. Well, you know, this is really strong authentication. Someone can watch over your shoulder and not be able to log in. I can do it right now. I can show something. This is the current half of my password for my stock account. Okay, you got that? If you know my password and that number right now, you can log in as me and, you know, sell stocks into a falling market. But that number is very hard to predict, one hopes, and it's hard to tell what the next one's going to be. So this is very powerful. We had people go out and do this, and I'd get phone calls, you know, this is Dennis Ritchie, I'm here in Israel, and the stupid little box has just stopped working, the battery run out or something, and we'd have to deal with that somehow. And of course, they'd have to carry something extra with them. Nowadays, we have something everyone wants to carry anyway. So this actually can solve the problem, and it is in many cases. It gets us out of the password game. There was no password in that login. Sniffing it, looking over the little, it's not there. And apparently it was 20 bucks. I had forgotten. That box was cheap. And of course, there are these things, which were used a lot back then. And in fact, I have one right here, which I also use for my stock account. And this has become quite popular. Now, it turns out, as I've told in my password talks for the last 30 years, these things are a little bit less secure than the one I showed you before, than this one. Because this one, you put the secret in there, or the administrator does. This one is based on a secret that the RSA Secure ID guys have. If they have the secret and they don't guard it, my device can stop works. And I said, but these are great. We've got both of these are so much better than passwords, you know, we'll live with it. Well, it turns out about 5 years ago, the magic secret at RSA got leaked. Someone hacked in and got it. And it caused a huge panic because these things were used a lot in the government. And all of a sudden they had to redo them and resend them out and fix it and so on. And of course, RSA, these guys, they're security experts. A lot of stuff they'd been waiting to do, they did all of a sudden because this happened. So it turns out these actually were less secure. I'm not saying don't use these. These are fine, and probably more fine now than they were. And even with the key stolen, for most people, it was more secure. But you know, you carry your keys to the car. Why not carry something to your computer, especially when it's important? When I was at AT&T 6-7 years ago, we actually had a software version of this that worked on my iPhone. You enter a PIN and then it gives you a passcode. And since I always have an iPhone, okay, so what do you do if there's a bad PIN entered? Do you give the wrong answer, which is confusing? Do you zero it because someone's trying to guess the PIN? This is a problem. So here we have, oh, those are two authenticators I've got on my phone right now. There's the Google Authenticator app and the VIP Access guys, and I have accounts that use either one of those. So there's other suggestions I give to people who are actually implementing these servers. Don't count duplicate password attempts. If you're a fast typist and it's, what's your password? It said no. Oh, maybe that fourth letter. Let's try it again. Blah, 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 blah. If I enter the same thing twice, that shouldn't count as 2 tries. It's just me. Now, if they're different, fine. I made a typo. But usually it's because you've forgotten it or got the wrong one. Make the password hint. Some places have password hints. Make it about the primary password. How about allowing a trusted party to vouch for the user? Your spouse should probably be able to unlock your access to the bank account on your shared account and lock the account in increasing time, and remind the user of password rules. Wait, does this account allow spaces in the special characters or not? Because I have a thing I do, and whether it's a space in it or not matters. So you still want your strong passphrase. Okay, let's make them fun, or at least easier. So here is a web page I have up there, cheswick.com/insult. And if you log in, you will get 10 random insults given back to you. These insults are generated by words from the Oxford English Dictionary. They are pretty remote and strange. This is a vocabulary test. It's probably safe for work. There aren't a whole lot of places that will get you in trouble if you call your computer your uncomely platter of dropsical cone nose residue. Anyway, you can log in there anytime you like. You'll get about 43 bits of entropy, 42 bits of entropy, and it's actually a pretty good password. You can get rid of the you and of and just do the wonderful words. And you know, if you have a long passphrase like that, after a little while, you remember it and you don't have to write it down anymore. And I have a couple of those I use. Okay, so let us switch here for a moment. Boom. To a service called What 3 Words? And I'll go full screen on this. We okay here, Debbie? Okay.
Yep.
Okay, so here's a map of the world. Let's go to the world. And we need to pick a place that we can go back and remember how we got there. And we have to zoom in on it. So I'm going to go, I've never been to the middle of Spain. So, whoops. This is not zooming as well as it does on an iPhone. Let's see, how about this little point right down here at the bottom? All right. Yeah, this is not zooming very well. Oh, there's a town here, okay? So I'm looking at 3, big point, little point, big point. I'm gonna go to the little point, go right to the end and zoom in. Ooh, that looks like sort of like a ski slope or something. Let's go to the ski slope, and we're going to go to the southern part right here. Now, what's happening here is this service divides the world up into room-sized squares and gives each one a name. So I need something in here. I'm not being able to zoom in as well as I'd like. Oh, come back here. All right, that sort of works. Does this work? Yeah. All right, we'll zoom in a little more. What do I want here? What's something that's memorable in this little fish-shaped thing? How about right here at the meeting, the intersection right there? Okay, there, I'm going to choose this guy. Can you see that? That bush where the 2 white lines come together. That's my password. And it comes out to the 3 words, application oogle uncertain. And if you zoom in again, if you can remember how I zoomed in and do it again, you got it there. And that's actually, those 3 words are actually a pretty strong passphrase. And they're typable. You could even put in the periods if you wanted, if that helps with the special characters. Now, it doesn't meet all of the Eye of Newt rules, so you have to figure out what to do about that. But that is a way to, if you have a password that's important, that can be used. And of course, you don't have to go there. You know, you can pick something a little more familiar. It could be grandma's mailbox. But you have to be careful. Don't make it something really obvious. Don't go to my grandma's mailbox because, well, it doesn't matter. So that's an idea for that one. So let's see, we come back here. You go away, Chrome, back to here, we're playing again. Okay, we're back on here. Here was an example of zooming in at the Rocket Garden at Cape Canaveral, or where the frog pond used to be in my youth, or a spot in the Adirondacks. By the way, there's an SKCD on this where he came up with 4 random common words. In this case, very famous. What was it? Battery horse staple. It's anyway. Oh, correct horse battery staple. Yep, correct. So those are 4 normal words. I could type that in pretty quickly. No Eye of Newt stuff. It's actually a strong passphrase, not these 4 random words. But if you pick 4 words at random out of a dictionary of 20,000, I'm putting myself on the spot, 4 words, that'd be 10 to the 16th. It's a big number. The computer's not going to guess it. Not user chosen, but the user can veto. And we're going to write it down for a while. We'll talk about writing down. So coming around here on slide 93, what is my advice for users? I have 3 levels of advice. There are some people who want my username and password because they want to know it's me, and I don't care whether they know it's me. Sort of example might be my password to log into the New York Times. You know, if you really wanted to log in as me in the New York Times, it's okay. It doesn't really matter. There are other passwords that are sort of inconvenient or stolen. Nowadays, maybe Amazon's not a good example, but you can imagine some where, oh yeah, you got to change it and it'll be a bit of a problem. And then there's ones that could be a major problem, like bank access, medical records maybe, and you know, stock accounts and so on. And I sort of work on 3 different levels of this. I do write them down, but I don't write the exact password down. I write something that reminds me of the correct password, and I usually get that right. Use variations to meet strong password requirements. Do note variations. My usual strong password, but no spaces, is something I would give. And of course, that usual strong password changes with each account I'm going into. Should you save your passwords in the browser? Little, not difference, defense, you idiot. Little defense. Defense, there we go. I like this. Little defense against keystroke logging. How about that? Which is, I'll talk about in a moment. Keyring protection is not a bad idea.
You misspelled defense.
Oh, I did, didn't I? How embarrassing. Oh, look, it's underlined and everything. How do I spell that correctly? Daffiness. Defense. We'll do the American spelling. How's that? Thank you for the feedback. And then there are these programs called password vaults. 1Password and LastPass are 2. There are a bunch of them out there. I do use them, though not all the time, because this little device, these smartphones, are actually pretty solid defense against attacks. I mean, the FBI has trouble getting in on them. That's not a bad thing. They allow a few things. First of all, they let you share your password among several machines if you do this. Also, you probably want to share your passwords with your spouse. If you get hit by a bus, going through somebody's password list is a real problem. And this is a handy thing to do. We have not done that as well as we should here in our house, but we're going to. We've got to do this. What I'd like to see is the engineering goal of a non-moronic password rule. None of this eye of newt stuff. I want a password to be something a friend, a colleague, an ace hacker won't guess in a few tries, and they can't figure it out while watching you type it. Now, if you got a video camera, they can still do it. This is an easy, obvious security rule. Grandma understands why, you know. If you're a cat person and your favorite cat is named Muffy, don't make Muffy your password, okay? And don't make it cat. Pick something else. So it turns out, though, we hear in the newspaper about a lot of the password losses. What's really going on? Keystroke loggers. If they break into your computer, what they want to do is see what you're typing and maybe even what you're clicking on. And if they can see what you're typing, they can get any password you type. And these are a real problem these days. And phishing attacks. Hi, your account is overdrawn. Click here to go to Wells Fargo Bank. And if you happen to have Wells Fargo Bank and maybe overdrawn, you might click there. And you may well end up in some site that looks like Wells Fargo, and you'll log in and try to give it your username and password, and they say, thank you very much. And then there's password database compromise, which you can't do anything about, all those hashes and stuff.
Chess, can I ask a question?
Sure.
Can I go back a few slides? So the one thing I've never felt comfortable with,
Yes.
all these different now programs that I think you mentioned it a few slides ago that will
Like 1Password and LastPass?
Yeah, so here's my question about that.
Yeah.
The ones that basically you just have to remember one super complicated password and maybe
Yes.
everything else.
Yeah.
Well, okay, so I have, if anyone knows enough about my background, this won't surprise you. I've always been nervous about anything that people get too comfortable with storing anything in because they believe that's never crackable. Because if one day I put all my passwords in that one site and I have one super complicated password, if that ever gets broken into, does that mean I am screwed for life for everything now?
This is the one egg, all your eggs in one basket question. I don't want those passwords available on some site that's not mine. At some point, I mean, you have to decide what your threat model is, right? Is some foreign government trying to get your stuff? Or are you just going to leave your phone lying around someplace, something like that? I consider the security in modern smartphones to be good enough for almost everybody. And therefore, if they store your passwords in the phone, that security is probably good enough and you shouldn't worry about it. Now, if you're sharing it with different machines, they have to put it on some central server. And they can do that by encrypting it. So they can't read it and no one else can read it. And the only way to read it is to type in that big passphrase you have. So you need to have one password to rule them all. And I've given you a couple of suggestions. If you went and took 2 of my insult generated lines and took 6 words out of them, you would have something that I think a major government would have serious trouble cracking. There'd be other ways they do it. They'd try to break into the phone and get in between you. But at some point, you got to draw the line. You're probably not responsible for the nuclear launch codes.
Have we met? Of course I'm responsible for the nuclear launch code.
Well, you wouldn't be telling me that if you actually were. And what's more, they wouldn't do this way. It's supposed to be on its own network, they tell me, and all that stuff. That, I don't know, that's a different problem. But generally speaking, this is a good solution for just about everyone. I'm hard pressed to think, you know, maybe, well, you're not going to have a password to get into the skiff. You're going to have you're going to have an armed Marine guard who recognizes you. Okay, that's who you are, authentication, and it does include the stick of dynamite. So when you really need to do it, you can do that way. But for almost anybody, this is good enough. I mean, one could sit down and do a security audit of this stuff, but I think it's about right. Answer your question?
Yeah, I still think that's somebody somewhere, somehow in the future. I mean, any
Well,
criminal is trying to figure out how to break that system.
yeah, of course, the future, one of the threats for the future is, okay, you can't compute it now, but someday computers will be faster. There'll be quantum computing, or what have you, and they'll be able to crack it someday. And they've recorded all your conversations, and they'll be able to go back and crack it and see what you said some time ago. And the problem, there is, as I think you probably know, there's a goal in cryptography to have something called perfect forward secrecy. So that even if you know that password, the first thing it does is set up a key that only the two endpoints know, and you can't recover with the magic master key. And therefore, in the future, it wouldn't work. And then you just pick enough bits. But I think you're going way, way beyond where we are today with these cracked passwords. It's an interesting problem, though. Thanks for the question. I should have the camera down here where you are. And let's see. Okay, so that's actually it. Thank you. Let's see how my watch is telling me it's time to stand up. That was 50 minutes, which is 100 slides. How about that?
Yay!
Yay!
I have
Okay,
a
you got
question
questions?
for you. Yeah,
Yeah.
I have one right here.
Hey, how are you? Bill?
Howdy.
So here's my question. I've been listening in with great interest. I thought this wouldn't be interesting, but actually it's fascinating.
Ha! I got you.
The bottom line to me, and tell me if I'm wrong, is passwords can only protect you from amateurs. A pro's going to get in there.
Well, this is sort of the question we just had.
Yeah, it's similar, but more
If you
general.
have two-factor, okay, so there are two kinds of attacks to worry about. There's a general untargeted attack. I want to capture 100,000 computers, or I want to go find a whole bunch of people who have bank accounts I can access, and I don't care who they are. And I could deploy some sort of attack that takes over computers and looks for Wells Fargo logins and sends all that data back to me. That sort of attack you should totally be able to resist with the two-factor authentication, especially. You really want that. If you're a targeted attack, you're a US senator or maybe a US senator's daughter, you're more likely to attract the attention of somebody who has a huge number of resources. And then you have to start thinking more about it. But even so, this stuff will slow down people very much. Here, I can get rid of the screen now, can't I? And maybe go to Windows to see who's there. Show, I don't know what I'm doing with this.
You can take it off screen share if you
Answered
want.
my question. Thank you.
Yeah. I don't think I'd worry about it unless you personally are, the governor of Georgia or something. And even then, their security is usually way below this.
Right.
It's the sort of thing that they worry about the president using his iPhone or whatever he's using. So
Right.
This is still not doing, stop share. There it is. That's what I want. Boom. Okay.
So does anyone else have a question for Bill? I'm going to unmute everyone.
Cool.
Okay, so if anyone has a question, go ahead and feel free to ask. I can't unmute Yael. So if anyone has a question, feel free to ask. I think we might be okay, Bill. I think that it sounds like everybody has had their questions answered.
Or have your fill of me, yeah.
I learned a lot, and I've heard this before, so I always learn something new. So I want to thank you. And just to reiterate, Bill is known as the father of the firewall. He is the one who wrote the book on firewalls and internet security. So I feel safe in getting this information from you about passwords because you or really the person who's been looking at this for so many years. So
Decades, yeah.
yeah,
Yeah.
I want to thank you very much, Bill, and I want to thank everybody who's come on today. So we're recording this. We'll make it available to you for afterwards if you want to watch Bill again and again. And anyway, have a great day, everybody.
And I will make sure that the web stuff is on, that the slides are up.
Great. Okay.
Okay?
All righty.
Okay, thank you all. Boom, boom.